All right. So today we're covering greatest common factor. Okay? Greatest common factor. Here's what I want you to do. I want you to write the factors. I want you to write the factors of 12 and 18. Okay, so write out the factors. So in other words, the factors of 12 be 1, 2, 3, 4, 6, and 12. Okay, the factors of 18, write those out. Okay, what are the factors of 18? Emma?
1, 2, 3, 6, 3.
No, not 3. Again. Do what?
9.
Yeah, 9. Yeah. Okay, so we have 1, 2, 3, 6, 9, and 18. Okay? So as we look at the two sets of factors, the 1 is in common, the 2 is in common, the 3 is in common, the 6 is in common. So 1, 2, 3, and 6 are in common with the two numbers. Okay? So of those factors, 1, 2, 3, and 6, the greatest common factor would be equal to 6. Okay? We also call this the GCF, okay, for greatest common factor. Okay? Now, those are fairly simplistic numbers, okay? 6 and 18, it doesn't take, 12 and 18 doesn't take a lot to figure out what the factors are, okay? So it doesn't take you a lot of time to do that one, okay? The problem is that they're not always going to be real easy numbers, okay? Sometimes they're going to obviously have to be harder. For example, let's look at 24 and 40. So we want to know the GCF of 24 and 40. Okay? Well, we can list out all the factors of 24 and 40. 24 is 1, 2, 3, 4, 6, 8, 12, 24. Okay? For 40, you have 1, 2, 4, 5, 8, 10, 20, 40. Okay, and as we look at these then, you have, obviously the 1 is going to be in common with every single number. Okay, so every single pair of numbers always has 1 as a factor. Now, sometimes that's the only ones that they have. Okay, sometimes the only factor that 2 numbers have or 3 numbers have in common is the number 1. Okay, I'll tell you about that here in a second. We have 2, we have 4, we have 8, and it looks like it's it. So, the GCF is equal to 8. Okay, that one wasn't real difficult, a little bit harder, but I guess when I'm listing out the factors, it's probably easier than when you have to, obviously. Okay, but there's got to be an easier way, and there is. Okay, there's an easier way to deal, especially with the larger numbers. Sometimes you can just see it. Okay, real honestly, I don't have to list them out to know that that's 8. Okay, but obviously I'm older than you and been doing this a lot longer than you, and so to me it's not that hard, okay? But there's got to be an easier way to do it. So when we get to numbers that have, let's say they have 12 or 14 factors, okay, what do we do then? Well, here's what we do. I'm going to take the same example, 24 and 40, okay? And my first step is I'm going to prime factor both numbers. Okay, remember, prime factoring is using either the factor tree or inverted division. Okay, either the factor tree or inverted division. Okay, I'm going to do one of them the factor tree way, and I'm going to do one of them the inverted division way. Do this one the factor tree. So I need two factors that when you multiply them together you get 24. Give me two factors besides 1 and 24. Staley, 6 times 4. Okay, is 6 prime? No. Is 4 prime? No. So I have to continue with those two numbers. What are the factors of 6? 2 times 3. And what are the factors of 4? 2 times 2. Those are all prime. Okay? So, I'm going to list it out. 2 times 2 times 2 times 3. Now, you will notice that I didn't use exponents. Okay? The reason I didn't use exponents is because of what I have to do here in a second. Okay? I went ahead and just wrote it out just like it's in expanded form there, and I'll show you why here in a second. Now, the 40, we have to prime factor. I'm going to use inverted division for it. That would be 2, 20, because with inverted division, you only use prime numbers. First prime number is 2. 2 goes into any even number, so therefore I'm just going to start with 2 and use it till I can't use it anymore. 2 goes into 20, 10 times. 2 into 10, 5 times. Okay? So it's 5 prime. Is it? Okay, so that's where I stop. Okay, so here's all my prime numbers with inverted division. All in a neat little row there, and that's why I like it probably more so than the other. Okay, now, here's what we're going to do to find the greatest common factor. Okay, I'm going to take, and I'm going to see which one of my prime numbers are common with both prime factors. Okay, so I have 3 2's. So I have to go 2 times 2 times 2. What is 2 times 2 times 2? 8. So the GCF, just like in our other example, is equal to 8. Okay, so that's a shortcut. Okay, a little shortcut that you can use, and they're going to say, there are a couple of them. The directions are going to say, find the greatest common factor by listing the factors of each number. Okay, I want you to do it using prime factorization. So everybody, perk up and hear. Okay, I want you to do all of them tonight using prime factorization. I don't care whether you use factor tree or inverted division. But where it says list the factors out, I do not want you to list the factors. Okay? I want you to do it prime factorization because you need to get used to doing it with prime factorization because we won't use listing factors realistically anymore. Okay? Because the numbers that you're going to be dealing with from now till the time you get out of high school are going to be larger than just, 4 and 8. Okay? But it's just good practice to go ahead and go ahead and do the prime factorization of each one. Okay? All right, now let's look at another example. Let me get one here. Let's look at this one. They want to know the GCF of 11 and 22. Real honestly, that's real easy. What's the greatest common factor that 11 and 22 share? 11. Okay? Now, let me show it to you using prime factorization because that's what they've asked you to do. It's not hard with prime factorization either. Okay? 11 is already prime, so I don't have to do anything to it. I have to prime factor 22. So this is prime. So the prime factorization of 11, here's where some of you will make a mistake. Okay? The prime factorization of 11 is just 11, not 11 times 1, because 1's not prime. Remember, prime factorization is the multiplying of all the prime factors of a given number. Okay? Well, 1's not prime. 1's not prime or composite, so we don't use it. All right, now, 22, if I prime factor it, is what? 11 times 2, or 2 times 11. Those are both prime. So here I have 2 times 11. Here I have 11. That's common. That's common. Now, you will notice something here. The GCF is just 11. It's not taking this 11 times that 11. Okay? Now, I'm going to write this down, and people don't ever, for some reason, don't ever remember this. Okay? But it will help you not to make careless mistakes if you will memorize this little statement I'm going to write down. Okay? So you need to write it down in your notes. The GCF will never be larger than the smallest number you are comparing. Okay, the GCF will never be larger than the smallest number you are comparing. Okay, so when we're comparing 11 and 22, which is smallest? 11 or 22? 11. So what I'm saying there is this. The GCF of 11 and 22 will never be larger than 11. It can be 11, as we just solved, okay, but it won't be 12, it won't be 13, it won't be 14, it won't be 15, and the reason being is can I multiply 12 times any whole number and get 11? Can I multiply 12, because it's supposedly this is the greatest common factor of the numbers. So it's a factor, so that means I have to be able to multiply this times something else and get both of my numbers. So can I take 12 and multiply it times a whole number and get 11? No, because what is 12 times 1? 12, okay? 12 times 1 is 12. So how could I multiply 12 by a whole number and get something less than 12? You can't, okay? So the GCF will never be larger than the smallest number we're comparing. So right up here, 24 and 40. The GCF can't be larger than 24. It could be 24, but it can't be larger than 24. If it is, then you've made a mistake. So if I look at this, and let's say I just say, for some reason, I said, oh, there's 11 there common and there's 11 there common, I multiply them together. Well, what do you multiply? When you get 11 times 11, what do you get? 121. So you're going to multiply 121 times something and get 11? No, you can't. Does 121 go into 11? No. 11 goes into 121, but 121, you can't do this, in other words. You can't take 121 and divide it into 11 and it go a whole number of times. You can't do that. Okay? So whatever GCF you get, okay, whatever greatest common factor you get right here, it must go into the other two numbers, the two numbers evenly. Goes into that one time, it goes into that two times. If the GCF doesn't go into both numbers evenly, then it can't be the GCF. You've done something wrong. Okay? Let's look at another example. Remember, you're supposed to be writing these examples down. Let's go with 99 and 121. Okay, the GCF of 99 and 121. All right, now, I want to prime factor both numbers. Okay, prime factor 99 using factor tree. Give me two factors of 99. Isaiah. 11 times 9, okay? So 11 times 9 is 11 prime. Yes, so I'm going to circle it. Is 9 prime? No. So I have to find two factors of 9. What are two factors of 9, Michael? 3 times 3. Is 3 prime? Okay? They're both prime, so I'm done there. So the prime factorization of 99 is 11 times 3 times 3. That's the prime factorization of 99. Now I have to come up with two factors of 121. What are two factors of 121? 11 times 11. Is 11 prime? Yes. So those are both prime. So my prime factorization of 121 is 11 times 11. Which prime factors are shared between the two numbers? Staley. Okay. 11 is shared. Now, do I multiply 11 times 11? No. So the greatest common factor is equal to 11. And to check, I would divide 11 into 99, 11 into 121. 11 into 99 goes 9 times, remainder 0. 11 into 12 goes once, be 11, remainder 1. Bring down my 1, 11 into 11 goes once, be 11, remainder 0. So it goes into there evenly. So it is the GCF, or is a common factor. Doesn't necessarily prove that it's a GCF, it just proves that it's a common factor. Okay, but it is the GCF because that's what we've come up with our prime factorization. Okay, now I want you to do this one on your own. 48 and 60. I want you to find the GCF of 48 and 60 using prime factorization. Okay, so step 1 is to find the prime factors. Prime factor it, either using factor tree or inverted division. So your first step is to find prime factor using inverted division or factor tree. Okay. Then you write the prime factorizations out of each number, and you find those prime factors that are shared between the two numbers, that are common between the two numbers. Okay. If there's multiple pairs that are in common, then you multiply one of those together. When you think you have the answer, go ahead and raise your hand. Mm-mm. 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 All right, let's look at it. Some of you are, a lot of you are not getting it yet. That's fine. That's why we're doing it. 48. Okay. The prime factorization of 48. 4 times 12. 2 times 2. 3 times 4. 2 times 2. Okay, so these are your prime numbers. So I have 2 times 2 times 2 times 2 times 3. Okay. Now, 60. 2, 30. 2, 15. 3, 5. Okay. So 2 times 2 times 3 times 5. Common. Those two are common. That one is common. That one is not common. So erase that one. But this one is common. So the ones that are common are 2 times 2 times 3. Okay? In other words, this pair here is there. This pair here is there. This pair here is there. Okay? 2 times 2 is 4 times 3. What is 4 times 3? 12. Okay? Most of you got 3, and I don't really know what you did with the 2s. Okay? So, let's do another one. 36 and thinking here. 72. Okay, prime factor in both. 36 and 72, prime factor both of them. There, and there, all common, right? So you have to multiply each one of those together. They're common over here, so you have to multiply that times that times that times that. All right, let's look at this one. If you're still working, continue to work on it. Prime factorization of 36. Okay, 4 times 9. 2 times 2, 3 times 3. Those are all prime. Okay, so 2 times 2 times 3 times 3. Prime factorization of 72. 6 times 12. I'm going to use inverted division here. 2 would be 36. 2 would be 18. 2 would be 9. 3 and 3. So 2 times 2 times 2 times 3 times 3. Ones that are common. 2 and 2. 2 and 2. 3 and 3. 3 and 3. So I take and multiply 2 times 2 times 3 times 3. 2 times 2 is 4 times 3 times 3. 4 times 3 is 12 times 3, 36. Okay? So, there's your greatest common factor. Now, quiet. All right, now, get a little harder. You find the GCF of 84 and 120. So you can see that you probably don't want to list all the factors of both those numbers. Okay? Obviously, that would take you quite a while to list all the factors of 84, then list all the factors of 120, then see which one is the greatest one. So obviously, then we want to go ahead and take and do inverted division or factor tree and factor it. Okay? I'm going to use inverted division for both of them because they're larger numbers, and for me, it's easier just to do this. I went 2 into 84 goes 42 times. 2 into 42 goes 21 times. Does 2 go into 21? No. Next number is 3 and 7. So 2 times 2 times 3 times 7. Now you have 120. 2 goes into 120. Well, 2 goes into 12 6 times. 2 goes into 0 0 times. 2 goes into 60 30 times. 2 goes into 30 15 times. 3 and then 5. So 2 times 2 times 2 times 3 times 5. There's one that's common. There's one that's common. And there's one that's common. The 7's not common. The 5's not common. And the third 2's not common. So 2 times 2 times 3, which is 12. Okay? And once again, remember, the factor tree or inverted division just gets you to this point here. Okay? All we're trying to do is get to that point. Okay? We're trying to get to that point right there. To do that, you either use factor tree or inverted division. Okay? All right. What happens if we have 3 numbers? Okay. For example, 12, 18, and 42. Okay. Let me ask you this. What is the largest number that could be the GCF of those numbers? 12 is correct. Okay. 12 is correct because could 18 be a factor of 12? 18 times what would give you 12? Nothing. Could 42 be a factor of 12? No. Okay? So 12 is the largest number that I could have for the GCF of those 3 numbers. The process doesn't change. To find the GCF, you still do the same thing. Prime factor. 4 times 3. 2 times 2. So 2 times 2 times 3, then 18. 3 times 6, 2 times 3. So 2 times 3 times 3. Then 42. 7 times 6. 2 times 3. 2 times 3 times 7. Okay? Well, common, common, and common. They have to be in common with all three prime factorizations. Okay? So, 3, 3, 3. Okay? Now, this one's not in common. Those three are not in common. So I can't use them. So my GCF then is equal to 2 times 3, which is what? 6. And that's your GCF of those three numbers. Okay? It has to be common. The prime factors have to be common with all three numbers. Okay, let's do a harder one. 28, 42, and 63. I want to know GCF of 28, 42, and 63. Okay? Eventually, you'll be able to see these prime factorizations in your head of these numbers. Okay? Right now, you can't because it's newer stuff to you. But eventually, you'll be able to do this in your head and know that this one is 2 times 2 times 7. Know that this one is 2 times 3 times 7. Know this one is 3 times 3 times 7. Okay, those are the prime factorization of those three numbers. Now, the largest factor that could be, or the greatest common factor of this would be, the largest one we could have would be 28. Okay, but I know it's not 28 because 28 doesn't go into 42 evenly, and 28 doesn't go into 63 evenly. Okay, the one that is in common with all three is this one right here. Is there any other common ones besides 7? With all three of them, is there any common ones besides 7? No. So the GCF is simply equal to 7. Because if I multiply it together, if I take 7 times 7 times 7, I'm getting a number a lot larger than 28. So I know in my mind I don't do that. I just write down the 7. Okay? Well, what if, like we talked about earlier, what if you had 15 and 16? Okay, well, the prime factorization of 15 is 3 times 5. The prime factorization of 16 is 2 times 2 times 2 times 2. Are there any in common? No. So the GCF is equal to 1. And they call this relatively prime. Okay? GCF, and I don't think, let me see here. No, you're good. Yeah. And they don't tell you have to write that. Eventually, in some of our books, they'll tell you, tell them if it's relatively prime. And all relatively prime is, it means that it has a GCF, or the greatest common factor would be 1 of both numbers. Okay? So if you have no prime numbers that are in common, then it's just simply 1. Okay? All right. I want you to Hey, it's called rain. Sit down. GCF, listen. GCF of 36 and 57. Okay? 57 is not prime. Okay? The reason I know it's not prime, because what is 5 plus 7? What is 5 plus 7? 12. Does 3 go into 12? Then 3 has to go into 57. Okay? So 19 times 3. So that's the prime factorization of 57. Now you got to do the prime factorization of 36, which is 2 times 2 times 3 times 3. So the one they have in common, 3. So GCF is equal to 3. Okay? Now understand that we're not finding all the common factors. Okay? We're finding the greatest common factor. All right? So your homework is 3.4, 5 through 28. Okay? 3.4, 5 through 28. Okay, still got about 5 minutes left in class, so go ahead and start at least the first one so you can, if you have any questions, you can run across those questions if you have them and you can ask.